Um, so just now we just have the class 1 here and the class 2 here, right? This is the likelihood. Again, this is the likelihood, okay? P of x given omega 1, and this is P of x given omega 2. All right. So oh, I forgot. I just erased the base rule. Again, I will write it down. P of omega j given x is equal to P of omega j, P of x given j divided by P of x. All right. This is x, okay? So now we can find this term already, right? Because we have two classes. We know the prior from that. For the class number 1, it has 3,000, right? And we also yeah, this is it. Right, so the plier for the omega 1 is just 0.6. So you can guess. No, you not guess. Actually, you know it's exactly. P of omega 2 is 0.4, right? Because it is 2,000 divided by 2,000 plus 3,000, right? So this can be the plier, right? Okay, so we know the prior already, and we know the likelihood already. This is the likelihood, and we know it already. So how can we know this, right? The P of x, the evidence. How can we know it? Basically, the P of x is simple. It actually is P of x is equal to so you just marginalize. No, you just px is just the normalization factor that make this term sum to 1, right? So it should be this j equal to 1 to 2 of omega j p of x given omega j. Okay, so basically the formula tells you that you just sum over the class, right? You just sum over the class. Just combine two classes together, okay? But before you combine it, you have to so basically you just multiply this term to the likelihood and then sum it, okay? So you just multiply each term here, the likelihood, by the plier, right? I multiply by P omega 2, and I again multiply here by P of omega 1, right? Okay? And then once I multiply it, it's gonna be the relative shape gonna be changed just a little bit, because in this case the plier for the class 1 is 0.6 and this one is 0.4, right? So this one's gonna be lower than before, right? This is the original one. This is the likelihood, okay? So once you multiply by this, it will be lower a little bit, something like this. So this is P of omega 2 multiplied by P of x given omega 2, right? And this is omega 1, okay? But I don't want to write it. Right now we're gonna find what is the P of x, right? P of x is, as I say, you just do it very easy, like this. For one x, for a given x, you just sum for given x, okay, for an x, you just sum this p omega 1 of okay, plus p of, oh, how about I write down here, p of omega 2 p of x. So to do this, you just given 1x, this is 1x, right? Oh, how about I write down here, given 1x here, you just sum this and this together, right? So basically you just sum for all x, okay? So you do this, you do like, you sum it, okay? Oh. So this is the sum of it, okay? Oh, sorry. Okay, this, so the black line here is the sum of these two terms, okay? So this black line is called p of x, all right? So now you're gonna multiply, oh sorry, divide the term here, each term, by the p of x, okay? So so around here, from this, you divide no, sorry, this one, and you divide by the black line here. So around here you will get around like 1 or something, and then here also you will get around 1, something like that. You know, you can do the division by yourself, right? You just pick a point here, and then you just divide the height. Maybe this is clearer. You just have the height here. The height here is p of omega 2 p of x. Suppose this point is called x12, okay? So x12 given omega 2 and divide by p of x12, all right? At this point. So once you do this, you will get the posterior. The posterior is the p of omega 2 given x12. Okay, so if you have like 100 of x, so you just do the same thing with all the thing here, all right? So that is called the posterior. So hopefully I don't confuse you too much, and hopefully you better understand the concept of these three things, right? All right.